So, I hope you can all see my screen. Someone just confirmed that they can see my screen.
Yes, we can.
Okay. So this is the first question in the paper one paper that has been that has been shared with you, the one that we're going to begin with. And it's asking us to show that xy is equal to 16, given that the log of x to base 2 plus twice the log of y to base 4 is equal to 4. Now, you see we're adding two logs, but to different bases. So the first thing that you want to do is change the base of one to the other so that you can add them and simplify them. So we could decide to change base 2 to base 4. Let me just rewrite the equation here. Given this, we want to show that xy is 16. So we could change the base 2 to base 4. And how do we do that? We write the log of x to base 4 and then divide it by the log of 2 to base 4. This is the change of base rule. And then we leave this as the log of y to base 4. Now you realize that 2 can be written as 4 to the power half. And once we do that, we'll be able to simplify what we have in the denominator. So we have this twice log of y to base 4, so that's equal to 4. So now the half can come out. So that would be the log of x to base 4 divided by a half times the log of 4 to base 4. But we know that the log of 4 to base 4 is 1. Because we know that it is 1, then we'll have the log of x to base 4 divided by a half, which is the same as twice the log of x to base 4. And now we have this being added to twice the log of y to base 4, and that is equal to 4. We know that the multiplier can become a power in logarithms. So this would be the same as the log of x squared to base 4 plus the log of y squared to base 4. This is equal to 4. And when you're adding logarithms, you multiply the numbers whose logarithms you're finding. So as long as it's the same base. So this becomes x squared, y squared. The log of that to base 4 is equal to 4. Now, from the definition of logarithms, the log of a number is the power to which the base is raised to get that number. So that would mean that from this statement right there, x squared, y squared is equal to 4 to the power 4. And if I just decide to raise both sides to the power a half, x squared, y squared, I raise this to the power a half, and 4 to the power 4 to the power a half. This gives me xy is equal to 4 squared, which is equal to 16. And I'll have proved, I'll have shown what I've been required to show. Are there any questions there? Yeah, so alternatively, you could have decided to change the one in base 4 to base 2, right? So that actually, you realize that when you do that, you would have this 2 log of y to base 2 out of the log of 4 to base 2, and you're equating this to 4. So you have the the log of x to base 2 plus 2 times the log of y to base 2, but this would be out of the log of 2 squared to base 2. I'm equating that to 4. So we have this plus this out of this. I'm equating this to 4. You realize that this takes us straight to the log of x to base 2 plus the log of y to base 2 is equal to 4, which we said we can write like this when we simplify it. And this gives us directly xy as 4 squared, which is 16. Yes, that was a really easy question, but you realize you need to know the rule about the change of logarithms and also really the basic definition of logarithms to jump from this step to this step or to jump from that step to that step. Yeah. If there are no questions, then I'll hand over to the next presenter to work on question 2.
Okay, ladies and gentlemen, ladies and gentlemen, ladies and gentlemen, I hope you can see my screen and hear my voice. So your presenter for today is a lady. Yeah, amazing. So let's go to the next question, number 2. If -4 minus 3i is one root of the equation, z to the power 4 plus 5z cubed plus 3z squared minus 59z plus 50 equal to 0. So since this is a quartic expression, we expect 4 roots of the equation, right? And since we've been given one root of the equation, -4 minus 3i, that means that its conjugate, which is -4 plus 3i, is also a root of the equation, right? So since we have both of those, we can get a quadratic out of them. Yes. So I'm going to go here. Z minus 4 minus 3i into Z minus 4 plus 3i. Yes. Then we'll have Z plus 4 plus 3i and Z plus 4 minus 3i, right? So we're going to calculate, since we already see the difference in squares, right? 7 plus 4 plus 3i, then Z plus 4 minus 3i. We're going to get the difference in squares, which will give us Z plus 4 squared minus 3i squared, right? We all know that I squared gives us -1, right? When we square this, we get -9. The negative gives us a plus, then we get 7 plus 4 squared plus 9. Okay. I hope you can see my letters on my screen.
Yes, we can.
As we were saying, so we're going to open up this equation here. 7 plus 4 squared plus 9 to give us 7 squared plus 128z plus 8 plus, no, let's see. This is not 8, this is supposed to be 16. Plus 16 plus 9. Then we get 7 squared plus 8z plus 25, correct? So now we already have, since we're going to want the other factor to get the other roots of the equation, so we're going to use for, okay, most times, like they taught us, like we were taught, we're going to use the long division method. It's the easiest one, which we're going to use, but the other methods you can use depends on your preference, but the long division method is going to be the easiest. So there, the equation is 7/4 plus 5z cubed plus 3z squared minus 59z plus, oh god, writing big letters. Oops, my apologies. Okay, so we have 7 the power 4 plus 5z cubed plus 3z squared minus 59z plus 50, right? And then in division method, divide by what we got here, which is z squared plus 8z plus 25. Yeah. So we're going to divide, we divide 7, sorry, z to the power 4, divide by z squared. Yeah. Then we multiply through. So z to the power 4 divided by z squared will give us z squared, right? Z squared. Z squared times z squared plus 8z plus 8z plus 25 will give us z to the power 4 plus 8z cubed plus 25z, right? When we subtract, we shall get negative 3z cubed minus 22z is supposed to be squared, z squared, right? So now we're going to get negative 2z cubed divided by this z squared here, which will give us negative 3z. I hope we're all par where of this so far. Yes, I hope we're all at par. Then negative 3z times z squared, right? So this will give us negative 3z cubed. Negative 3z plus 8z plus times 8z will give us negative 8. Yes, will give us yes, negative 3z times 8z will give us negative 24z squared. Then negative 3z plus 25 will give us negative 75z. Then subtract this. Negative 22 minus, this one will cancel out, giving us a 0. Then negative 22z squared minus 24z squared will give us plus 2z squared, right? Plus 2z squared. Then negative 59 minus 75z will give us plus 16z, right? Yes. Then you bring this 50 here. The plus 50 comes down. Yes, so we start 2z squared divided by this z squared there, which gives us just 2 plus 2. 2 times z squared plus 8z plus 25 will give us 2z squared plus 16z plus 50, which subtracting with gives us a 0. Yes. So now we can find the other roots of the equation using this expression here. This one here. Yes. Z squared minus 3z plus 2. So this is 1, 2, and 7 squared minus, get the factors, so give us minus z, minus 2z, close this, give us minus 3z, and factors of 2, and plus 2, and then we get z into z minus 1, minus 2 into z minus 1, then we have z minus 1, z minus 2, correct. So the other roots of our equation are 1 and 2, which comes from, no, now we have all the four roots of the equation from our quatic expression. We have the four roots, which is negative 4 minus 3i, negative 4 plus 3i, and then 1 and 2. So those are the other roots of the equation. Any questions? These are easy things, right? Right, guys? Let's see. I hope that's what we all got for the equation. Yeah. Right. Wait, someone asked me I'm doing which step? Which step did you ask? Which step did you want to know about? Miss Julian. Yeah, which step did you ask about? Please. Let me see. The first step, like which step exactly? Unmute and ask the question, please.
I'm asking the very first step, you did.
Like getting the conjugate of this root, of this root.
Now the next part where I have z minus negative 4 minus 3i, then brackets, then z minus negative 4 plus 3i.
Oh, because we want to be able to get this expression z squared plus 8z plus 25, the quadratic, the factors of that expression, negative 4 plus 3i. We want to get the quadratic of it and be able to get the other factors from this thing here, this quadratic expression here. Yes.
Okay.
You got it, yeah?
Yes.
If it comes in USE, you pass, eh? Is it a yes? You pass, right?
Yeah, I'll pass.
Lovely. Okay. Okay, so we're done with, okay. You can also use some of the roots and product of the roots to get that expression. Yes. And after that, you can go to the next number 3, as the next discussant comes.
Hello, good morning. I hope you can hear me. I'll be taking through question 3, and it says prove that cosec 2 theta plus cot 2 theta is equals to cot theta. Hence, solve the equation that so we are going to first do the proof from which we shall solve the equation. So cosec of 2 theta plus cot 2 theta can also be written as 1 over sine 2 theta plus cos 2 theta over sine 2 theta. And this gives us 1 plus cos of 2 theta divided by sine 2 theta. And then also cos of 2 theta can be written as 2 cos squared theta minus 1. And that means we shall have 1 plus 2 cos squared theta minus 1 divided by sine 2 theta. And also sine 2 theta can be written as 2 sine theta cos theta. So that means we have 2 cos squared theta divided by 2 sine theta cos theta. And this is going to give us cos theta out of sine theta, which is cot theta. Now we are going to solve for that equation. So we are solving the equation. So since you have already made the proof, we can make the conclusion, yeah? Left-hand side is equals to right-hand side. Or you can go all the way and write the expression. Yeah. So now we are now solving, but since you have already made the proof, so we can just take cot theta being equal to 2. This can be written as 1 over tan theta, which is equals to 2. And that implies that tan theta is 0.5 or a half. So we're going to find the acute angle corresponding to that, and that is the tan inverse of 0.5, which is which is 26.7. 26.7 degrees. So if we are to sketch our quadrants, we see that the acute angle or the tan ratio we have here is 0.5 and it is positive. That means our angles have to lie within the first and the third quadrant. So definitely our acute angle 26.7 is in the first quadrant, so theta can be equal to 26.7 degrees. And then we're also seeing that it's positive in the third quadrant, and the third quadrant, there are angles between 180 and 270 degrees. So to 180, we are going to add 26.7 to give us the next angle. And that's going to give us 206.7 degrees as the next angle. And we would go again, but remember our restriction is that the angle theta has to lie between 0 and 360 degrees. So that's only one revolution. So that's why our angles are just 26.7 and 206.7 degrees. Are there any questions? Okay, since there seem to be no questions, I think I'll invite the next presenter. Yeah, and also if you are not in the groups, the link is going to be shared, and also you can subscribe to our YouTube channel. Thank you.
Morning. I don't know if I can be heard. Would anyone tell me if I'm being heard or
Yes, you are.
yeah? You can be.
We can hear you.
Okay, thank you, Wanga. Yeah, so morning guys. I'm going to take you through question 4. So for question 4, the question says the line L1 passes through the points A and B, whose position vectors are 3i minus j plus 2k and minus I plus j plus 9k respectively. When in vector form the equation, the line. Yeah, so you have those 2 points, A and B. So in most cases, it's very good for you to follow the arrangement the question has given you. Of course, someone may be thinking about a B and an A, but like remember that's going to affect your directional vector or the direction of your vector, because you, for this case of A and B, you'll be having AB, then the symbol. Then this guy was taken B and A, will be having B, A, and then the symbol, either that or B, A, and then this arrow up. Yeah, so my advice would be always go with the arrangement the question has given you. If the question starts with point A, then take the directional vector A, B with the arrow up. That's what I would advise. So to do this question, first of all, we need to write down the general equation of a line in vectors, which is R is equal to A plus lambda, then D. Yeah. So that's what we have. So this is the general equation of a line. It's the general equation of a line. And okay, it's not good to just cram this equation. It's good to understand that for a line, you can have the parametric form of the equation of a line, you can have the Cartesian form of the equation of the line, and then you can have the vector form of the equation of a line. And what you're seeing right here is the vector form of the equation of a line, because you can see the A as the symbol, the D as the symbol, the R as the symbol. So it's very good to understand the different ways the line can be represented, and also even the plane has different ways it can be represented. Then I won't stop there. I'll also go ahead to elaborate what these letters mean, because maybe sometimes your teachers don't tell you what they mean. Now, the R, for example, implies a general point on this line. Then this point A implies a known point on this line. And then this thing that looks like a y upside down is a parameter, a variable that changes, a variable that can change. It can take on any number, any value. And then the D is what they call a directional vector, or the direction of the vector. Some people also say it's a vector parallel to this line. Yeah, so it's very good to understand what those different symbols mean. So now to begin off, so I'll say now, because R is a general point on this line, that means I have X, Y, and Z. And then now also ideally, like I've told you, it's good to take the direction as A and B, meaning that this A, the known point, should be the first point you're given as A. By the way, I should put this down. The position vectors of these points that you have been given are 3, -1, and 2. By the way, that I you're saying was supposed to be a J. It's just a typo. And then the position vector of point B. Now notice I'm using small letters. That's because these are position vectors. So this is -1, this is +1, and then 9. Then you don't forget the brackets. So so now the known point that I was telling you about is this one, the A guy. So it's the one I'll put here. So this will be 3, -1, and 2. So that's the known point on this line, plus our parameter, the variable that can take on any value into. Now it's always best to do this on the side. Now D, vector D is the same as this vector. In other words, the direction of the vector, which is the same as -1, 1, 9, the position vectors. This is 3, -1, and 2. So when you subtract this, you get -4, this is 2, and this is 7, if I'm not mistaken. Yeah, that should be it. So we come back here to the equation. We feel that this is -4, this is 2, and that's 7. Yeah. So this part of the X, Y, and Z is actually pretty unnecessary. We can just leave the R the way it is, because they just want the equation. So this would be, so actually I've basically finished. 3, -1, 2, whatnot, plus the parameter into -4 to 7. Yeah, but math teachers are very tricky guys. You know, you'll leave it in this form and then you see an S0. That's because they want you to take it back to how the question looks. So meaning that R will have to be equal to 3i minus, now this is the, okay, this is also a vector form, but okay, actually, to be honest, this is the parametric form. Then what I'm going to write is the vector form. Yeah, this is the vector form plus 2k. As long as you see the symbols of I, J, and K, just know you're in the vector form and you'll get your A1. This is -4i plus 2j plus 7k. So what I have here is the vector form of the equation of this line. What I had previously would be taken as the parametric form. Actually, if I had proceeded here with my X, Y, and Z, I'll take these guys the other side. These are the 3, the -1, and the 2, and then I'll remain with the parameter into this. So what I had initially was the parametric form of the equation of the line. The answer is the vector form of the equation of the line, and then there is also the Cartesian form of the equation of the line, which is that guy you guys are used to, Smania 8 minus 1 out of something is equal to y minus maybe 0 out of maybe 2 is equal to maybe z out of minus something out of what. This is the Cartesian form. This is parametric, and our answer is in vector form. Does anyone have any questions, or that's it? Mhm. Okay, so if there are no questions, I'm going to assume that this question was very simple. So, yeah, so we will just move on to the next question. Thank you for your time.
So welcome back from the short break. So this is question 5, and it's the one that we're going to be doing. Question asks us to find the locus of a point which moves such that the ratio of its distance from the point to the point A to the point B is 2 to 3, right? So if we were to have a sketch of a certain one of such points, let's call it point P. We want that AP, the distance AP, when we compare it to the distance PB, is in the ratio 2 to 3. So the length of PA divided by the length of PB should be 2 out of 3. You realize that this is the same as saying 3PA should be equal to 2PB. Now I'm going to square both sides because I know that when I'm finding the distance between 2 points, there's a square root involved. And so to do away with that square root from the onset, I'm squaring both sides straight away. Now this point is an arbitrary point, so we're going to give its coordinates x, y. Point B is negative 5, 3, and point A is 2, 4. So how do we find the distance between 2 points? So PA it's going to be x minus 2 squared plus y minus 4 squared. Now it's supposed to be a square root, but we already squared, and hence the square root is dealt with. So similarly, on this side, we'll have x minus 5, which is plus 5, and then plus y minus 3 squared. Once you reach here, you've really done the work of the question. It's now up to you to expand and expand correctly. So this is x squared minus 4x plus 4 plus y squared minus 8y plus 16. And this is equal to 4 times x squared plus 10x plus 25 plus y squared minus 6y plus 9. Okay, you want to expand further. This is 9x squared plus 9y squared minus 36x minus 72y plus 180. I've added the 4 and 16. And this is going to be 4x squared plus 40x, plus 4y squared minus 24y plus 136 when you add the 25 and 9. You collect like terms, put everything on one side. We have 5x squared plus 5y squared minus 76x minus 48y plus 44. And equate this to 0. And this is the equation of the locus of the point which we have been asked to find. Now, you can tell that this is a circle. Why? Because the coefficients of x and y, the coefficients of x and y, x squared and y squared are the same, and there's no term in xy. So you can tell that this is the equation of a circle. Now that means the locus describes a circle. Now, if you wanted to just check, if this equation is correct, yeah, we are certain from ratio theorem that if I take a point, let me call it P prime, and if we have such a point P prime, such that P prime lies on AB, I can get a position vector of P prime using ratio theorem. This would be twice the position vector of OB plus thrice the position vector of A, rather, twice position vector of B plus thrice position vector of A, divided by 2 plus 3. Now, when you work this out, you'll have 2 times negative 5, 3 plus 3 times 2, 4. This is out of 5. So we're going to have 1 out of 5. I think when you simplify that, you have negative 4, 18. And so the point P actually lies at negative 0.8, 3.6. Now, so we know that P prime should lie on this circle, right? Since it satisfies, it's one of the points that splits the distance AP and PB in the ratio 2 to 3. In other words, it's one of the points whose distance from A is 2/3 its distance from B. So that means P prime should lie on this circle. And indeed, when you substitute this point in the equation of this circle, it holds. So that's just one way of confirming that your locus is correct. This is to check. If there are any questions, I'll be ready to take them. Otherwise, we can have the next presenter coming up to do question 6. Hello?
Excuse me, I want to inquire about the number of justice pastor.
The number?
You have just discussed about the locus.
The locus?
Yeah.
Yes.
There's something I'm not seeing. Right? How do you tell that you're actually coming from this point to the other point? Like, how do you know that it's maybe, let's say, you say AP and then BP? Why is it not AP, PB?
Okay. So distance doesn't matter, yeah? Distance doesn't matter. So you could use PA and PB, or you could use AP and BP. For distance, it doesn't matter. Why? Because AP is the same as the length. AP is the same as the length PA. You're just you could say that it means AP means I'm coming from A and going to P, but for distance, it's just the distance between 2 points. So there it doesn't matter. However, when you're talking about vectors, it's different, right? When you're talking about vectors, it's different. AP is not equal to PA because AP means you're going from A to P. PA means you're going from P to A. You realize that in this example, we're actually calculating distance, and that even if you switched A and P, you'd still have the same values on this line because we're dealing with distance, not vectors. You can see in the question, it says ratio of its distance, and not ratio of the vectors. So in this case, we're dealing with distance and not vectors. However, in the ratio theorem, you use vectors, but you use position vectors. So it's not really something that you have to be worried about, but it's just something to take note of. AP is in fact equal to negative PA in terms of vectors. But for distance, the distance AP is the distance PA. It's like saying the distance between Kampala and Jinja is, say, 80 kilometers. Doesn't matter whether you measure it from Kampala going to Jinja or measure it from Jinja going to Kampala. But going from Kampala to Jinja is different from going from Jinja to Kampala. I hope that makes sense. Is the question answered?
Please. Thank you.
Okay. Unless there is any other question, I will hand over to the next presenter.
Hello everyone, we are back and we're going to number 6. So given that x is equal to 1 plus cos 2 theta and y is equal to sin theta, show that the squared y dx squared minus 4 dy dx cubed is equal to 0. So first things first, we're going to differentiate x is equal to 1 plus cos 2 theta and then y is equal to sin theta, yeah? So this will be a, oh my gosh, oops, sorry. Okay, okay. We have x is equal to 1 plus cos 2 theta. Then you have y is equal to sine theta. So the x d theta first, right? The x d theta is equal to, so we see that we have a double angle here, and that will give us -2 because the derivative of course negative sign, right? And this is yes, I hope that par -2 sine theta. Then dy d theta here will give us cos theta, right? Because the derivative of sine is cos, there's no negative. Now found the expression for dy dx, right? Dy dx will give us dy d theta times d theta dx, right? Then we already have dy d theta, then we need to get the inverse of this. So it will give us cos theta times 1 out of -2 sine 2 theta, right? Cosine, cosine. Then I'm going to expand this using a double angle formula. And then I'll have cos theta out of, this be -2, sorry, oops, sorry, oops, sorry, yeah, yes, so 4 sine theta cos theta, because this gives us a 2 times this -2 is negative, or negative is up here, put it up here. Then the cos disappears, like bye-bye, and then we're left with -1 out of 4 sine theta, right? Then, but, so how do I dx is equal to -1 out of 4 sine theta, right? But then our sine theta is equal to y. So dy, if we can see that dy dx will be equal to -1 out of 4 y. Can we all see that? Any questions at this step? Anyone curious, inquisitive, wondering? Okay, this is no question. Let's go ahead, because I remember as you're working out, you have to look at what the question says. Our eyes should still be here. You see? We should still be looking at this. We want to find a way to find this expression here as we calculate. So far we have our dy dx. Now we move further. So back in high school, okay, right now in high school, they taught us that when you're finding a second derivative, right, yes, second derivative, d squared y dx squared, it's the same as d dy dx, all this dx, right? That's what they taught us. That's what I had. Can verify. If it's not what they taught you, tell me and you can use your method. But I think it's what they taught us. Yeah. Okay, so this will give us the negative 1 out of 4. I want to bring y up here. Will give us y negative 1, because this will be easier to differentiate using a chain rule, right? Dx. Yeah. So when I use a chain rule on y to the power negative 1, when the negative 1 comes down, right? So we're going to get 1. Sorry. Oops. Sorry. Okay. Yeah. Oops, sorry. Okay. So using the chain rule on y to the power negative 1, right? So d squared y dx squared will give us 1 out of 4 y to the power negative 2, right? dy dx. Because we're differentiating y, so dy dx still comes here. Yes, so this is our expression for d squared y dx squared. Now we can see that I want to simplify this. Oh, oops. Yes, I want to simplify this. And our negative 2 is the same as y negative 1 squared, right? We agree with this step. This y here is the same as this, right? But I don't want to show that in my calculation because it will be messy. So we're gonna go ahead and any question? Okay, any questions? No question now. Okay, so we are going to get the expression for this, which will be the same as negative 1. Sorry, why do I keep putting negative? My apologies, ladies and gentlemen. Okay. Oh my gosh. Excuse me. My apologies, ladies and gentlemen. So, yes, okay, so we're going to get 1 out of 4 y to the power negative 1 squared, because I want to get this expression here. You know, we had negative 1 out of 4 y to the power negative 1 here, right? Anyway, we're still here, dy dx. We are reaching somewhere, right? Then okay, so our expression here where we had dy dx is equal to negative 1 out of 4 y to the power negative 1. I'm going to make this a subject y to the power negative 1 so that I replace dy dx somewhere here, because we're still looking at our question here. Yeah. So this will give us -4 dy dx is equal to y to the power -1, right? Then we're going to replace this expression here into here. So I'll have d squared y out of dx squared is equal to 1 out of 4 into -4 dy dx squared. Then we still have a dy dx here. Yes. Okay, we are moving somewhere. So we'll have squared y dx squared is equal to, so -4 squared is 16, right? 16 divided by 4 will give us 4, right? Then we're going to put a 4 here. Then dy dx will stay inside here squared. And dy dx squared times dy dx to give us dy dx cubed, right? So we are close. We are close. This is close to that according to the question, yeah? So how wonderful and exciting. So we are approaching to our final destination, d squared by dx squared minus, we're going to bring this one here, the other side to our left hand side. So -4 dy dx cubed is equal to 0. See? Wonderful, guys. Let's see what we got here. This is our answer. Does anyone have any question? How I got here? The steps in between? Do you have another way to go about it? I mean, you can go another way where you maintain the cos and the sine, but man, you take like, unless you're a genius, okay, unless you, pardon?
You have not understood.
At all, eh?
Yes.
From
I
where?
beg your pardon. I joined late.
Pardon?
I joined late. I caused you to repeat, but you
Oh,
Could you please shed more light on the second derivative?
the second derivative is this step here.
Yes.
Oh, okay. So the person wants me to repeat. I start from the beginning. I start over. Okay, now let's start over. Just start over. Lovely. They say it from the,
Yes.
okay, excuse me. Okay, we're going to start from the beginning, step by step, slowly, that we all understand and are par. Given that x is equal to 1 plus cos 2 theta and y is equal to sin theta, show that d squared y dx squared minus 4 dy dx cubed is equal to 0. Yes. So I'm going to start. We have x is equal to 1 plus cos 2 theta. Yeah. So we're going to differentiate each of them and find an expression for dy dx. Yes. Separately x and y. So here dx d theta, yeah, is equal to -2 sine 2 theta. Do you all understand how that comes about? Then just drawing in. Then
That's
y, pardon? Pardon? Okay, next, y is equal to sine theta. And if you differentiate this, dy d theta will give us cos theta. Yes, are we all at par with this? Now, to find dy
Yeah.
dx, we're going to get dy d theta times d theta dx. Dy d theta we already have it, and that's cos theta. And then the theta dx, we're going to reverse this one. We get times 1 out of negative 2 sine 2 theta. Yes. Then cos 2 theta, sorry, cos theta out of, we'll put the negative here. When you expand sine 2 theta double angle, we're going to get 4, because it's 2, comes to 2 times this negative 2 is 4. 4 sine theta cos theta, because we're trying to eliminate the double angle in this, right? So this negative is still here. I'll put it up here. So cos theta, they go away. They cancel out. Yeah. Okay. Okay. So dy dx, yeah, is equal to, since the cos has gone up, we have negative 1 out of 4 sine theta. Yes. But then our sine theta is equal to y according to this, right? So we have dy dx is equal to negative 1 out of 4y. We have to keep looking at the question where they want us to go. Oops. Yes. Where they want us to head is this, or I should stay focused here. So now we are going to get the second derivative of this expression here. And from what we learned that the squared y dx squared is equal to dy dx dx squared. We agree with that, right? Right. Now, so we're trying to get the second derivative of negative 1 out of 4y dx squared. Yeah. So in short, we're trying to get, I'm going to remove a quarter, negative 1 out of 4, put it outside. Then we're left with the y negative 1 dx. Right? Do you agree with that? Do you agree with that?
Yes.
Okay, wonderful. Right. Okay, so this will give us, we're going to use chain rule on the y to the power negative 1. Yeah, when we use chain rule, negative 1 will come, and then this will cancel. Negative 1 times negative a quarter. We stay with a quarter. Sorry, you can see this well. Okay. Okay, so we'll have a quarter y to the power negative 2 dy dx. Do you understand this step?
Yes.
Wonderful, exciting, lovely. Okay, so we'll have this squared y dx squared is equal to a quarter y to the power negative 2 dy dx. Yeah, and this is the same as a quarter y to the power negative 1 squared dy dx. Yes, this is the same as this, right?
Right.
And then from our first equation, what is it? This one here. This is dy dx is equal to -1 out of 4 y upon -1. And y upon -1, if I make it that circular formula, I'll get -4 dy dx. This is from this. I'm going to substitute this into this formula here, because we're trying to reach where we're reaching. Then we're going to have the squared y dx squared is equal to a quarter into -4 dy dx squared times dy dx. Yes.
Okay.
Okay. And then we're gonna have d squared y dx squared is equal to -4 squared is 16. 16 divided by this 4 here will give us 4. And then dy dx squared, it's squared, right? I'll just write it here. A quarter times 16 dy dx squared times dy dx. Okay, 4 1 by 4 1 by 4 4. 16 divided by 4 is 4. And then this times this will give us dy dx cubed. It is close to what we have in the expression in the question. So I'm gonna bring this expression this time on the left hand side, and we'll have what they have asked us to do, which is -4 dy dx cubed is equal to 0, and that's the thing they asked us, which is QED. Any question? Any question about anything? Anything we've gone through? A clarification, an inquiry? Yeah? Okay. No questions. So that means the thing is easy. Okay, it's not, but man. Okay, I'll invite the next discussant. If you have any questions, please ask now or forever hold your peace. Not forever. Okay, let us see the question. Got it. Lovely. Precious, you're gonna excel and ace, and every one of you. Thank you so much. Next discussant will be coming for number 7.
Hello everyone. I'll be taking you through question 7. And it says by using small changes, show that the fifth root of 244 is 3 times 1 over 405. And then also we're going to estimate the cube root of, or the square root. That's square root. Square root of 9.01. Yeah, so small changes. Small changes all starts from this, that as delta x tends to 0, then change in y over change in x tends to dy dx. And the fact that it tends to dy dx then also implies that the change in y over the change in x is approximately equal to dy dx. And also that implies that change in y is approximately dy dx times the change in x. And this is very fundamental for this question or for this application. Now, it's an estimation because 244 is not a perfect root. It's not like it doesn't have perfect fifth root. So we have to look for a number that is in the neighborhood of 244 that has a fifth root. And if you're to check, the closest is 200. If you're unmuted, please mute. Okay. So the closest 244 is 243, which is 3 power 5. So what we are going to do is because now you've started the solution for part A, we shall say let y equal to x power 1 over 5. Yeah, for which x is 243. So if x is 243, then that means making a small change in x will cause a small change in y. So y plus change in y, which is caused by making a change in x. So it's x plus delta x power 1 over 5. So if x is 243, it implies that x plus delta x is 244. And therefore, delta x is equals to 244 minus x, which is 243. That's 1. So we are saying that we already have one of the parts for this expression, that's the delta x. Now the next thing we will have to do is find dy dx. And now dy dx from y equals to x power 1 over 5, dy dx is equals to 1 over 5 times x power negative 4 over 5. So all this we are trying to do is we're trying to find y plus delta y. So we're finding y plus delta y. But then we have seen that we can express delta y as a function of the first derivative and the small change in x. So we are going to find dy dx when x is 243. So our dy dx is equals to 1 over 5 times 243 power negative 4 over 5. And that's going to give us dy dx as oh good. Okay. Help me calculate that. I didn't copy it, but okay. It's going to be 0.2, that's 1 over 5 times 243 power negative 0.8. Which is 1 over 405. So we have what dy dx is there. Yeah, so now we are going to find y plus delta y. And of course, from
from y is equals to x power 1 over 5, we have y as 3, because x is 243, which is 3 power 5. So this is just 3. Y is 3. So therefore, y plus delta y is equals to 3 plus 1 over 405. And this can be also written as 3 over 405. That is part A. And I think that's clear. If there are any questions, you can ask. However, let me first be doing part B. So part B says estimate the square root of 9.01 to 3 decimal places. So again, it's the same idea. We are going to look for a square that is close to 9.01. And of course, when we think about it, 9 is the closest. So we can say let x equal to 9. Yeah, for which y is equals to square root of x, which is that's 9 power half, and that is 3. So that's why y is 3. So now the next thing we're going to do is have to find delta x. And from what we have discussed from part A, we know that x plus delta x is surely going to be 9.01. So our delta x is going to be 0.01. So the next thing we have to do is find dy dx. So dy dx is equals to p dx of x power a half. And that is a half times x power negative 1 over 2. So that means our dy dx is our dy dx is a half times x power negative a half. So the next thing we are going to do is find change in y, which is approximately dy dx times change in x. And this will be dy dx at x is equals to 9 times change in x. So that means we have a half times our change in x, our x, which is 9, power negative a half times our change in x, which is 0.01. And that gives us our change in y as approximately 0.00167. So therefore, our y plus our change in y is going to be approximately, since it's an estimate, it's going to be approximately our y was 3 plus our change in y, which is 0.00167. And that's approximately 3.002 to 3 decimal places. Are there any questions regarding that? Okay, seems there are no questions. If there are questions, you can please ask. You can unmute and ask, or you can type it in the chat. Yes, please.
Excuse me.
Yes.
There are situations where you're given, let's say, trig functions.
Trig functions.
For example, and more so, like they give you like tan of 46 squared, and they square that. So how would you
Something
go about?
like
Do you first get the tan 46, then you square it, or you go about with the square?
It is.
That's the question.
Okay. In having this, it should imply to you that y is equals to tan squared theta. Okay.
Yeah.
So that means you have to look for an angle that is close to 46, for which that tangent is something sort of exact or a pleasant. Do you get?
Yeah.
So of course the nearest we have is 45. So that implies that this 46 we have here is theta plus delta theta. So that means your y, because of the fact that this is a 46, you have a small change in y. And then it will be equal to tan squared of theta plus delta
the small
theta.
Okay.
But then remember this expression I've written here. The change in y is approximately the y dx times the change in x. Where for this case you remove your change in x and put change in theta.
In theta. Yeah.
So for this case, we shall have our change in y as dy d theta times that. So your task will be to find dy d theta from your task will be to find dy d theta from here, from y is equals to tan squared theta. So you find dy dx from that. Okay. I hope that's okay. And then after finding your dy d theta from that expression, you're going to find your change in theta. And for this particular scenario you have given, your change in theta is going to be just where theta is 45 degrees, yeah? So your change in theta is just 1 degree, but you should change this to radians. So to be 1 over 180 times pi, and that is the value you would use for this particular scenario. I hope that makes sense. Is Francis still on? Because he was on asking. I think it's off, but yeah, that's what you could do in such a scenario. If there are no other questions, then I think I would love to invite the next presenter. Again, just to say the recording for this is going to be in the YouTube channel. Yes, please.
Just on what Francis was asking about.
Yeah.
Like, when do you actually tell that it's supposed to change into radians and not?
When in calculus, when you're dealing with angles, they're usually in radians. That's one thing I can say. It's safer to deal with them in radians.
Even if it's the standard line, it's the standard angle, it should be in radians.
Exactly.
All right, thank you.
Kali. Okay, thank you very much for being a good audience. I'd love to invite the next presenter. Okay, guys, what's up? Just want to confirm again if I'm being heard well, like if my audio is okay.
Yes, it is. We can hear you well.
Okay, thank you so much, man. I needed that clarification. So we are meant to go through number 8. Yeah, so number 8 says okay, sorry about that. I was trying to check the chat and see because I was seeing a message. So number 8 says find the volume of a solid generated by rotating about the y-axis, the area enclosed by the curve, the y-axis, and that line. Okay. Yeah, so this question was a high-end question. It wasn't very, very simple to get the answer, but we shall go through it. So first of all, what I want to do is write down what we have. We have this curve, y squared plus 4x is equal to 9. So this is like our first equation.
I'm using it for studying.
Guys, sorry, my bad. Like what I realized, this question, it has a big solution. So I'm going to work from the corner. Sorry, I wanted to erase to work from the corner. Like from starting from that point. Yeah. So what I was saying is I wanted to first write down these equations that we have. Is equal to 9. I'm really sorry about the handwriting. But for a person who's just joining us, I'm first writing down the equations, like what we have. Y is equal to -2. This is equation 2. And then finally, we have the y-axis. But we know that the y-axis is x is equal to 0. So that is equation 3. So that is what we have. Yeah. So when you look at y is equal to -2 and x is equal to 0, now obviously, see, this question demands plotting or sketching. And if you don't sketch, you know that you've missed those marks, so you won't get the full 5 marks. So obviously, we need to sketch. And of course, as we are sketching, we are not going to put in all the vagaries of Semenya getting the turning points, Semenya getting all that jazz. First, what you're going to do, we have been given y is equal to -2 and x is equal to 0. So what you're going to do, we have this major equation of the curve, which is y squared plus 4x is equal to 9. All we are going to do is substitute these values into that equation. And whatever answers we get are the ones that help us to sketch our curve. Like they are the ones that will show us how our curve is situated. Instead of going through all the other things of Semenya, you get the turning points, the what. That's section B. But since this is section A, we don't have a lot of time, and the solution has to be precise and to the point. So what I'm going to do, I'm going to start with y is equal to -2. That's where I'm going to start from. So I'm going to say y squared plus 4x is equal to 9. Using equation 2, y is equal to -2. So this will be -2 squared plus 4x is equal to 9. This is 4. Yes, plus 4x is equal to 9. 4x is equal to 9 minus 4. X, no, 4x will be equal to 5. Yeah, so x here will be equal to 5 plus 4. So what this means is that this curve, it's for the line, for the curve y squared plus 4x is equal to 9, and the line y is equal to -2, they'll be meeting at an x coordinate of 5/4. But that will make sense when you draw the graph. So I'm going to just proceed. Then I have y squared plus 4x is equal to 9. Now I'm going to use equation 3, x is equal to 0. So that will be y squared plus 4 is equal to 9. So this will be y squared is equal to 9. So y, this is a very important step, by the way. You have to show the square root sign. If you don't, you're biasing the way you're going to be marked. You can't just say things were obvious here. So y is equal to plus or minus 3. There is nothing like discarding the negative here. We need it. So I'll draw a boundary. Now, realize that we have an x coordinate and we have y coordinates. So you can imagine a person who went through the other things of getting turning points and whatnot. I basically now have what I need to sketch. The word there is to sketch this curve. So these are my axes. Yeah. So because I have those points that I need for the curve, I go straight to the point. So the up point here is 3, and the down point is negative what? Is negative 3. Maybe just guys, the only thing that I need to tell you is that yes, I've simplified life here, but at the same time, I need to know and understand the nature of this curve. What do I mean? The equation is y squared plus 4x is equal to 9. So because you're going to third term, I assume that you guys have covered coordinate geometry too. So someone with a keen eye would do this, would say y squared is equal to 9 minus 4x. And that person with a keen eye would realize that this is the equation of a parabola. Now, the moment they realize that it's the equation of a parabola, they know how to what? How to what's the word for it? How to make their curve. In other words, for them, they will know that this is just an example. They will know that their curve will have to be like this, or will have to be like this, or will have to be like this, or will have to be like that. Yeah, so this is also vital information. So after we have gotten the X and the Y and whatnot, we also need to know what kind of curve this is. Is it a hyperbola? Is it a parabola? Is it an ellipse? That kind of thing. And if I'm not mistaken, this should be the equation of a parabola. So, and now there are many forms of the equation of a parabola. This one in particular can be compared with this form. Y squared is equal to negative 4ax. This one in particular, because if I'm to rearrange this one, sorry about the handwriting. If I'm to rearrange this one, it would be y squared is equal to negative 4x plus 9. This would be y squared is equal to negative 4 into x minus 9 over 4. I hope your teachers told you that the coefficient of this x should always be a positive 1. So whatever has been attached to it should come out of the bracket. That's why I've factorized out the negative 4. Now, if I'm to compare with a general form, y squared is equal to negative 4x. There are some things here that are similar. For example, you realize that x, which is equal to capital X, is equal to 0. Actually, sorry, remove that x. It should be x minus negative 4 out of 4 is equal to capital X, which is equal to 0. Such that x is equal to 9 over 4. Now, someone is probably going to ask me, why am I saying is equal to capital X is equal to 0? Now, the y and the x stand for, if I remember correctly, they stand for the coordinates of the vertex. And the coordinates of the vertex for the general form, are always what? Are always 0. Because the curve, this curve is actually a C. It's a C curve. But now because this is a minus 4a, the curve is tending towards the what? The negative side. So this is a general curve. So, and the capital Y and the capital X are representing the coordinates of the vertex, which is 0 for the general curve. But now the curve that we have is y squared is equal to negative 4x plus 9. So that means our vertex cannot be at the origin. That's what it means. So we also needed this background info to come and sketch this guy thorough. We needed that background info because the sketch is actually going to be marked. And if your sketch is wrong, that means your sketch is wrong and everything after it should also be marked wrong, if I remember correctly. So, so now we know. So now, guys, if you work this out, its vertex is at 9, is at 9, 4. That 9, 4. Now, this vertex has an x coordinate and a y coordinate. Now, because this was just y squared, it means that it's the y coordinate is 0. Had it been y squared minus some other value like -4, that would mean we cannot take it to be what? We would say, since they are both squared, this guy here, and this guy here would leave the power out and it just equate the y's, the small y to the capital Y. And you realize that this capital Y is equal to 0 for the general form. So because this is just y squared and there's nothing else like y squared minus 4, that means that the coordinate of the coordinate, that y coordinate of the vertex of this side of this parabola is 0. But its x coordinate of the vertex of this parabola is given to us as 9 minus 4. Why? Because this was a negative x plus 9. When you factorize, it became x minus 9 out of 4. So that means our x coordinate is going to be here where this 9 out of 4 guy is. Yes. So we have the vertex of the parabola, and now we also know that this parabola hits the y-axis at +3 and -3. This guy there and that guy up there. Yeah. And then we also know that with the line y, let me actually put it there, with the line y is equal to -2, like this line is going to hit this curve at an x coordinate of 5 out of 4. That's the implication. Yeah, that's the implication that this curve at the line y -2, that coordinate, in fact, I'll put it for you guys. So let's first form the curve. The curve is moving like this. Remember, we have established it's C, but on the negative side. So it goes through its vertex. I'm so sorry again for the handwriting. Like that. That's how it's supposed to be. This can look neat, of course. Yeah, so that's how it's supposed to be. Now, this is what I was meaning. This is the line. Y is equal to -2. Now, at this point, this point there, that x coordinate is this 5. It is that 5 out of 4. That's what it means. So guys, that's our curve. So you can see how this background information helped us. The background information of knowing that this was the equation of a parabola, and then solving these two lines with a curve. In fact, that's what we did. We solved the curve with those two lines. Y is equal to -2 and x is equal to 0. That's what we have. So I'm going to draw a boundary here because now we need to determine the volume. We need to determine the volume. So now, the question says that find the volume of us. So the question says that it has been rotated about the y-axis. About the y-axis. So that doesn't mean we are moving like up, down, up, down. Because it has been rotated about the y-axis, we are moving left, right, like this. Let me do it like this. We are rotating it in that direction from, like, let's say right to left. If it was being rotated about the x-axis, then we'll be moving like up and down, something like this, up and then down, something like this. You can try to imagine that in your mind, but now we are moving left, right, or right to left, sideways, in other words, about the y-axis. So now, since we know that, I want to draw the element strip, the element strip, and it will be like this. This is how the element strip should be like. That initial 2D guy that we transform to the 3D guy, was that volume is 3D and the area is 2D. So this is the original 2D guy. We are going to transform it into a 3D kind of thing. Yeah, so that's the element strip that is going to be rotated about the y-axis, left to right or right to left. Yeah, so now we know that for when we are rotating, the equation is the volume pi, the integral sign. I can make this b, and I can make this a into y squared dx. Yeah, now, of course, some people just cram this, but this thing has an origin. The origin is the cylinder. Origin is the cylinder. Now, this part here is what we call the change in x. And then this part here is the y. Yeah, so this is length and width. So the length is the change in x on the axis. It's there. It's the horizontal guy. And then we have a height of 5. But yeah, and a height of 5. Yeah, so that's what we have. And so the volume of a cylinder is pi r squared. Pi r squared should be pi r squared h. Pi r squared h. Whereby this is pi obviously remains. Now this r is the y squared, and then the h is the change in x. Now, when you have so many, when you sum up all these small elements, these small strips within this area, that area, then that's when, of course, you'll be using this symbol initially, but that symbol changes to this one, the integral symbol. Then this becomes volume equal to pi, can be put outside the integral, because now you're summing up very, very small strips of very, very, very small elements, and it becomes that. So if just in case you are just from this and you wanted to understand it, that's where it comes from. Yeah, so it comes from a cylinder. Yeah. Now you're probably like thinking like I was a few minutes ago. That's why I posed that it has to be this has to be 2y. But no, that won't be the case. Won't be the case. That would be the case for the what? For the actually it now makes sense to me now as well. It would be the case for if we are rotating about the x-axis, because now we have a y up and like a y down. So it ought to be like a 2y guy, something of that kind. But because you're moving, this whole element is just being rotated left, right, like at a high rate, at a high speed. We just take it as y, just y. So volume, but I beseech you to look for an even better explanation at 9. So this would be y squared, sorry, pi. Now the limits are, they are here. The limits are of this curve are -3 and 3. Why? Because this curve has been bounded between x is equal to 0, the curve itself, and the line. But for the line, let me see. Oh yeah, so the line is here. This is y is equal to -2. Yeah, it has been bounded there. Yeah. So that the limits would still be the limits would be -3 and 3. Yeah, -3 and 3. Then now this y is now coming back to the equation of the curve, y squared plus 4x is equal to 9. But because the change is in x, because this is a dx, not a dy. So what I want to do is I want to make x the subject. So I would say actually, sorry, let me remove this. I'll just say y squared, because we already have y squared here. I'll just say y squared is equal to 9 minus 4x. That's what I would do. Yeah, because since the change is in x, I just substitute for the y. I don't want to integrate with, I don't want to integrate when this thing is still y. I just substitute for it. So this would be 9 minus 4x.
Excuse me.
Dx. Yes, please. Yes, please.
I have a slight question. Aren't you rotating about the y-axis?
Yes, we are.
Then why is it that the strip we are getting is a strip about the x-axis?
Oh, okay. Yeah, that's a good question actually. Well, what I can say, okay, I try to explain it in this way. You see, we have made our curve like this, but now like the interpretation that I have is that if you're rotating about the y-axis, that means it's like we are imagining moving from left to right or right to left, but rapidly, like at a very fast rate. But remember, if you're rotating about the x-axis, then you're moving up and down, up and down. I don't know if you're imagining that in your mind. You're moving up and down, up and down, up and down about the x-axis. Unless Oh, sorry. I think, yeah, I think I get you. I get you. Sorry. Yeah, you're right. You're right, actually. Because I get you. I get you. Y-axis translates to no, but if you're rotating about the y-axis, the y-axis is the line x is equal to 0. So it's still this line. It's still the vertical. It's still the vertical. Yeah, it's still the vertical. And to rotate about that vertical, it's moving from left to right, or right to left. But if it was the x-axis, which translates to the line y is equal to 0, that's the horizontal. So you'll be moving up and down, but rapidly at a very fast rate. Yeah. So we are moving from left to right, or right to left, depending on what you want, either left, right, or right to left. But we are rotating about. Yes, please.
Um,
Mm.
me, my concern is about the limits we are using.
Yeah. I knew someone was going to ask
You
that
have
question.
you have y squared, right?
We have y squared, but notice that I
You have
substituted
the,
for it.
let me just bring out my thing.
Okay, there's no problem.
You're having y squared, and for y
Mm.
squared, you're going to substitute, right? And then have x. Yet the limits we have are with reference to the y. How is that?
Yeah.
I also
Are
think
you
it should be
adding?
dy.
Guys,
I thought that.
no, guys, when I was actually working out this thing, that part also, by the way, it got to me. But yeah, you guys are right. This actually has to be a dy. It has to be a dy. Yeah, that's true. So meaning if we come back to this equation of y squared plus 4x is equal to 9, that means it has to be 4x. Let me see. Yeah, it has to be 4x is equal to 9 minus y squared, such that, if I'm not mistaken, x is equal to 9 minus y squared out of 4. Out of 4, such that, like, let me first erase. Let me erase some things here. Let me erase this and this, and let me also erase. Yeah. So I've made x a subject such that this should ideally be 9 minus y squared out of 4. Now, before I proceed, the guys that were asking a question, are we on the same page, or I still need correction in my work? Are we on the same page, or there's something else that you're thinking about?
Yeah, but then like considering this where we are, then I still think the strip is meant to be gotten about the y-axis. Because if you're getting the strip about the y-axis, that's what will make now dy. That's what will make this thing dy now. Then the radius will have to become the x-axis, such that we have 9 minus y squared divided by 4, which will be now like our radius of the strip we are getting. Then now even when we integrate, it becomes, over that entire limits on the y-axis, something of the sort. I don't know.
I feel as if you've confused me a bit. Feel as if you've confused me. Okay, for me, okay, I get your point, because now the confusion is how we are rotating. That's the confusion. Are we rotating up and down, or left to right? And for me, like, I was saying it that if it's a vertical, like this, then actually, let me do this. Let me put the arrow. If it's a vertical, then you have something like this. And if it's a horizontal, then you have something like this. Up, down, then like left
So on the
to right.
So
Yes,
on
please.
the vertical, how do you obtain the strip?
Okay, I get you. So now coming back to my sketch, this element strip that I have, that is the strip. But don't look at it as like as cut in between by this line y is equal to 0, which is the x-axis. No, look at it that this entire strip from up and down is going to be rotated left, right, the whole thing, the way it is, the way it is. Don't look at it like,
Okay.
don't look at it that it has been divided by the x-axis that you have now up and down. No, look at it as the whole thing moving left and right rapidly at a very fast rate, such that you create, I think, either like a cylinder. Look at the whole thing.
Okay.
Yeah.
Excuse me. Excuse me.
Yes, please. Yes, please. Yes, please.
For us, the way we are told,
Yes, please.
we are given the formula for finding that volume rotating about the y-axis as volume is equal to pi integral of x squared with respect to x, with respect to y, sorry, dy. So the x
So
must be pi integral of x
x squared,
squared, but not y squared. Yeah, x squared, then dy. Because we are
So
talking
in
about the
other,
y-axis.
so in other words, I correct my first thing here, this one here.
Yes.
Yeah, that one is true. Thank you, by the way, for that. Thank you. I had to correct it just like I corrected the substitution. So it had to be x. That's true. Then we substituted it from, yeah. Now before I go further, does anyone have any other concern? I want to see that you're on the same page. Yes, please.
Since we're rotating about the y-axis and the line y is equal to -2, shouldn't our limit be -2, not -3 and 3?
Yeah, I also agree. That it's just that this -2 here, where the eraser is, let me see, where is it? No, here where I've placed the eraser. It's just that it was helping us to get the x coordinate. But ideally we shouldn't take it that we are the limits are -3 and 3, because they stated the line y is equal to -2. So yes, this is a -2. It's a -2. If that line had not been stated in the question, then we'd have taken our limits as -3 and 2. So I agree. I really agree. Before I proceed, does anyone have any other concern or that's okay? Yeah. By the way, that's why I began by saying this question was a was a good one, because I personally had to also think. But I don't know if this is okay with everyone for now. Silence means that it could be the case. So what I'm going to do, I'm
Wait,
going to
sorry.
read. Yes, please. Yes, please. Yes, please.
What did we conclude on the limits? Is it -2 and 4?
Okay. So according to the other person, I didn't get their name, but I remember it was a girl. She said that the question has y is equal to -2. So because now notice that when we punched in, where was it? When we punched in 0, yeah, that like x is equal to 0, our answer became where the eraser is. Our answer became is equal to ±3. Yes. Now that would be for a question that just had a y-axis, but this question had the curve, y-axis, and the line is equal to -2. That's why I sided with the other person by saying that our lower limit should start from -2, but the upper limit, that one will remain as +3. So I don't know if it's okay with you. Is it okay with you?
Yes, it's fine.
It's okay. Okay. So guys, as you notice, I don't have enough space here, but okay, I don't want to assume that you guys know how to substitute this. Okay, of course you are told, but it's also good that I show you like how I also would do it. So much as the space is little, I'm going to proceed. So this is 9 out of 9 minus y squared out of, sorry, scratch that. scratch that. I have to integrate. Scratch that. So sorry, guys. So sorry. I have to integrate. Now, I'm going to just simplify things. Let me come here to the corner. This is 9 out of 4 minus y squared out of 4. Now, instead of wasting time, I know that this will be okay. Let me also first. No, it's okay actually. It's okay. Yeah, so I can represent it in that form, where it is up there in the corner. Let me just highlight. Then if I integrate, this should be 9 out of 4 x, then minus
Wait,
y.
sorry, can I ask a question?
Yes, please.
Isn't that whole thing supposed to be squared?
Whole thing?
Because you said x is equal to 9 minus y squared out of 4, and we're using x squared.
Yeah. Thank you so much. Thank you. Yes, it's squared, because for volume that either y or x is squared. Yes, it's actually squared. Okay, so let me also erase this. Come and erase this. So I'm saying it's a bit bulky now, but we can find a way of simplifying this. So this entire thing is squared. Okay. So this is pi integral +3, -2. So this will be 9 minus y squared squared out of 16 dy. So now this would be v is equal to pi out of 16 integral -2 3. Then I have 9 minus y squared squared. This will be 81 minus 18 y squared plus y to the power 4 dy. I don't know if people are agreeing me to that step, but just in case you don't agree, you can tell me. So now what I want to do is now bring in the instruction to now subtract the limits. So this is 81 y minus, now I'm just going to rush. Okay, I'm not going to rush, but because of the limited space, when I integrate this is 3. So this should be 6y cubed plus y over 5, y to the power 5 over 5. Then this is 3 and -2. Yeah, so just in case you don't agree with what I've done, please feel free. Yeah, I should be correct up to that point. So this will be now v pi. Now, because this is an instruction, this simply means, much as it's going to be bulky, this simply means that I'll have like those brackets there. I'll have 81 into 3 minus 6 y, sorry, minus 6, sorry, this had to be 3, yeah? Sorry. This had to be 3. This had to be 3 because we are now substituting cubed plus 3 to the power 5 out of 5, like that. Minus, let me come down, minus 81 into -2 minus 6 into -2 cubed plus this is bracket -2 to the power 5 out of 5, bracket that, bigger bracket. Yeah, so that's what we have. So the rest is just a calculator. That now, because this is being recorded, I think you won't mind if I erase the beginning part. I think it's okay. So I will erase. Oh, okay. Yeah, so we are concluding. Yeah, so that has gone. Now, guys, since the remaining work is just a calculator, all that is left to say is your answer, something here to be a decimal something with pi. You can leave pi the way it is. Yeah, you can leave pi the way it is. Then cubic units. Yeah. Yeah, the pi will be accepted because pi is an irrational number. So it goes on until who knows when. So you can leave, your answer can have pi. Actually, I think it should have pi because pi is irrational. So your answer should have pi. Pi. Irrational meaning that it's a number that cannot be stated clearly. So your answer should have pi. So guys, that's it. Unless anyone has any question for me, but that's the working. And good thing this is being recorded. So these many steps, you just see them on YouTube. Is it okay? Okay. Either I have confused you or I have affirmed what you know. Nonetheless, I have to close it here. Thank you, guys. Hello, everyone. Hope you can hear me and see my screen. We're going to continue to paper 2. And these questions have been shared in the group already. And if not, they are going to be shared in the chat. If you can't access the group, they're going to be shared in the chat. Even the link for the group is going to be shared in the chat. So yeah. So yeah, we're going to start with paper 2. It says a force vector F, which is equals to Pi plus 12J, has a magnitude of 13 units. Firstly, we have to find the two possible values of P, and for each value of P, we have to find the unit vector force. I think it's important to note that that we are finding two values, and also at the end, you're going to find unit vector force, and we have a magnitude of 13. So given, we are given that F, our force, is equals to P I plus 12J. And this can be written as just P12 in the brackets. Yeah. So we have a magnitude of 13. That means if I find the magnitude of F, then I can equate it to 13. So that implies that magnitude of F, which is equal to P squared plus 12 squared or half, is equals to 13. So when we square both sides, we end up with P squared plus 144, which is equals to 169, and P squared is equals to 25, for which P is either positive 5 or negative 5. And that's just part A. So you can say that as you conclude, therefore F you can call it F1 is equal to 5I plus 12J, or F2 is equals to negative 5I plus 12J.
Yeah, that's part A, and I think it's pretty much clear. Then part B says for each value of P, find the unit vector force. What we understand is a unit vector has a magnitude of 1. Yeah, should have at the back of your mind. And of course, as when you see the word unit, you have to be able to relate that. So find the unit vector force. So for P is equals to 5, we have F is equals to 5I plus 12J. If you're going to find the unit vector, it's important to find the magnitude of F and then divide through the X and Y components or the I and J components by that magnitude. And you will check that if you find the magnitude of that vector you get after doing that, the magnitude is going to be 1. So unit vector, which is written as this, with that thing on top, is equal to vector out of magnitude. Yeah, vector divided by magnitude. So in this case, we are dealing with F, and magnitude is of F. So magnitude of F, we have seen it is 13. So that means our vector, which is 5I plus 12J, is going to be divided by 13. And therefore, your unit vector F is equals to 5 over 13I plus 12 over 13J. So similarly for P is equals to negative 5, of course the unit vector will be negative 5 over 13I plus 12 over 13J. Are there any questions? Okay, looks like there are no questions. Yeah, so these are our solutions to this question. Yeah, thank you for listening. Hello. Yeah, so for number 2, you're not done with the solution. The solutions will be shared in the group. But this is it. You can take a screenshot, but this will be shared in the group, so don't worry about that. Let me move to number 2 so that we save time. Our time has really gone. So this is a simple statistics question for a particular set of observations. We've been given the total frequency. We've also been given the summation of x squared, and we've also been given summation of fx. Now, you should know that the mean, okay, these are formulas that I know you know. That mean is summation of fx over summation of f. And the reason this is so, because this is in fact the sum of all the items. And this is the summation of the frequencies, the number of items. So this checks out. And this is simply 563 out of 20. And your answer there is 28.15. There's nothing special there. Standard deviation, we know that the standard deviation is the square root of variance. So we first find the variance and then we can find the standard deviation.
The variance is going to be the summation of fx squared out of summation of f minus the mean squared. That's what the variance is. And so this is 16143 out of 20 minus 563 out of 20 whole squared. When you work this out religiously, it's 14.7275. So your standard deviation for this data is going to be the square root of 14.7275. That's going to be 3.837624 decimal places. Are there any questions there? I think that was pretty straightforward. So moving on to the next question. Question 3, the probability question. We're being told that the probability that a fisherman catches fish on a clear day is 2 out of 5, and on a cloudy day it's 7 out of 10. So being asked to find the probability that the day is cloudy given that the fisherman does not catch any fish, if the probability that the day is cloudy is 3 out of 5. Now there's we can use Bayes' theorem, yeah, to solve this. And I'm just going to outline the steps for that. I'm going to use a tree diagram to solve it because the tree diagram is easier to understand for most people. But I would also like you to see how it is and how it would come out in Bayes' theorem. So let F be the probability that he catches fish. Yeah, let F be the event that he catches fish. Yeah. And so F prime will be that he does not catch fish. It's good practice and a good habit to label these events. If you just use F in the question, it's not going to be very clear what you're using F for. So it's always good that you actually define any variables that you're going to use in your solution. So the probabilities that were being given are the probability that you'll catch fish given that the day is clear, and this has been given as 2 out of 5. Now, because in our question we're interested in him not catching any fish, it would be important for us to find out what this probability is that he does not catch fish given that the day is clear. And that's going to be 1 minus 2 out of 5, because either he catches fish or he doesn't catch fish when the day is clear. So this is going to be 3 out of 5. Now, we've also been given the probability that he catches fish given that the day is cloudy. And this is 7 out of 10, meaning the probability that he doesn't catch fish on a cloudy day is going to be 3 out of 10. These are very important, yeah. So let's keep note of them. Now, we've also been told that the probability that it's going to be a cloudy day is 3 out of 5. Now, the question doesn't say it, but we assume that it's either a cloudy day or a clear day, and that there are no other options. So the probability of it being a clear day will therefore be 1 minus 3 out of 5, which is 2 out of 5. Now, what does the question want? The question wants the probability of it being cloudy given that he did not catch any fish. Now, you might know the formula for this conditional probability, that this is the probability of it being cloudy and him not catching fish out of the probability of him not catching fish. And this can be expressed as the probability of him not catching fish given that it's cloudy times the probability of it being cloudy You can see that that's in the intersection. Out of, now we have probability of him not catching fish. Now we can split this into two. We can split this into him not catching fish when it's cloudy and him not catching fish when it's clear, because we know that these are mutually exclusive events, because there's no intersection between being cloudy and clear. It has to be one of the two. So if I want the probability of him not catching fish at all, I can add the probability of him not catching fish when it's cloudy to the probability of him not catching fish when it's clear. And that further simplifies to probability of him not catching fish given that it's cloudy times the probability of it being cloudy. So we do a similar thing in the denominator for each of those terms. So we'll have probability of him not catching fish given that it's cloudy times the probability of it being cloudy plus the probability of him not catching fish when it's clear times the probability of it being clear. Now, when you do this, at this point, then you simply substitute. You simply substitute for those values that we already have. So probability of him not catching fish given that it's cloudy is 3 out of 10. And the probability of it being cloudy is 3 out of 5. This will be out of 3 out of 10 times 3 out of 5 plus him not catching fish when it's clear is 3 out of 5. Probability of it being clear is 2 out of 5. So when you work this out, that's going to be 9 out of 50 out of 9 out of 50 plus 6 out of 25, which is 12 out of 50. So that will be 21 out of 50. This is 9 out of 21, which is 3 out of 7. So you can do this, right? And this gives you the correct answer. This is Bayes' theorem being applied. But for some people, it's not very easy to understand. And so a tree diagram would suffice. So we start by splitting first into it being clear and it being cloudy, because those are like the base conditions, if I could say so. This is 2 out of 5, and this is 3 out of 5. And when it's clear, the probability that he catches fish is 2 out
over
of 5.
5.
Exactly. So this leaves this as 3 out of 5.
3 over
And
5.
exactly. And when it's cloudy, probability that he catches fish is
3 over 5.
It's 7 over 10. And then him
Yeah,
not
7
catching,
over 10.
him not
Sorry.
catching fish would be 3 out of 10. So at this point, remember, this is what we want. I just changed the color for emphasis. This is what we want, right? And so we are going to apply this very formula right here to get what we want. But now we're going to use the tree diagram. And so that probability of it being cloudy, given that he's not going to catch any fish, is going to be the intersection of cloudy and him not catching fish. You can see that's going to be 3 out of 5 times 3 out of 10. You can see it clearly in the tree diagram. And then probability of him not catching fish would be all the paths, the sum of all the paths that end in him not catching fish. So you can see we have the first one, which is 2 out of 5 times 3 out of 5. The second one, which is 3 out of 5 times 3 out of 10. You can see this gives us the same answer we got above. Are there any questions? Yes, I've seen that there's a hand raised. Infinix X. Yes, please.
I beg your pardon on the tree diagram. and also the method, that method of
Bayes
probability
theorem.
of cloudy, not cloudy.
Okay. Let me just try to go through everything again. You can lower your hand now. The question wants us to find the probability that the day is cloudy given the fisherman does not catch any fish, right? Now you need to understand first of all that that probability is equal to this. I don't want, of course, if you want to pass it, you can cram that. That's how conditional probability is. Probability of the intersection divided by the probability of the condition. But what we are really finding is that we are going to enter a situation whereby we're saying the fisherman is not going to catch any fish. Now, on a day when he doesn't catch fish, it could either be a cloudy day or a clear day. We want to establish the probability that on a day when he has not caught fish, what are the chances that it was a what? It was a cloudy day. And to do that, we look at the probabilities of on days he didn't catch fish, what was the probability that it was cloudy? Or you could say what was the probability that it was clear, and then you get the complement of that. But that's really what the question wants us to find. Now, because of this formula, let me just write it. Let me try to write it here in a separate space. Yeah? The probability of A given B is equal to the probability of A intersection B divided by the probability of B. And similarly, the probability of B given A is equal to the probability of B intersection A, which is the same as A intersection B, divided by the probability of A. This means that I can write the probability of A intersection B as the probability of B given A times the probability of A, or the probability of A given B times the probability of B. And you realize that this expression of the intersection is what we're using here. It's also what we're using. It's also what we're using here. We have, wherever there's an intersection, we've replaced it with a conditional probability times the probability of the condition. Now, the question tells us already, yeah, that the probability of a fisherman catching fish on a clear day. So in that case, being a clear day is the condition. So that tells us the probability of F given clear is 2 out of 5. And so we can imply that the probability that we can infer that the probability of him not catching fish, therefore, on a clear day will be what remains, which is 3 out of 5. That's how we get these probabilities here. The probability that he catches fish on a cloudy day is 7 out of 10. So given that the day is cloudy, the chances that he'll catch fish are 7 out of 10. That's this condition right here. And therefore, the chances that he won't catch fish on a cloudy day will be 1 minus 7 out of 10, which is 3 out of 10. Now, the question wants cloudy given that he didn't catch fish. So now they are saying, they are trying to make him not catching fish or catching fish the condition. And now we want to look at the probability of the weather. Yeah, we're now looking at, of course, it feels confusing because you would think that the weather is what affects him catching fish or not, which is true. But now we are looking at the event has already happened. On a certain day, he didn't catch fish. We want to see what are the chances that that day was cloudy or it was clear. We want to be able to tell that, okay, on this day he didn't catch fish. Most likely it was a cloudy day, or most likely it was a clear day. So we do that by looking at the track record, yeah, the track record of days when he didn't catch fish. And then we see the chances of when it was clear and chances of when it was cloudy. That's actually kind of what the tree diagram showed. Because the tree diagram will show you that, okay, we have our base conditions, the weather, it being clear and cloudy. We know that chances of it being cloudy are 3 out of 5 from the question. Therefore, chances of it being clear, 1 minus 3 out of 5, which is 2 out of 5. And we've been told that on days when it was clear, chances of him catching fish 2 out of 5, meaning that him not catching fish 3 out of 5. And chances of him catching fish on a cloudy day are 7 out of 10, meaning that chances of him not catching fish on a cloudy day are 3 out of 10, which is 1 minus 7 out of 10. And so, if we use this formula right here for the probability of him catching fish, of it being cloudy, given that he didn't catch fish, the probability of it being cloudy, the intersection of two events is when they both happen, right? So probability of it being cloudy and him not catching fish would be this path right here. That path right there. And so we multiply those probabilities to get the probability that of it being cloudy and him not catching fish. And then we divide that by the total probability of him not catching fish. That's the denominator, total probability of him not catching fish. So we add all the paths that end up in f prime of him not catching fish. You have one path there, and then you have this lower path that we've already counted, which is what makes up the denominator. And you realize that what's here in the denominator is exactly what's here when you use Bayes' theorem, because the tree diagram is just really a visualization of Bayes' theorem. I hope that makes sense, Mr. Infinix.
Yes, thank you.
Okay. We shall proceed to the next question, question 4, which is a mechanics question. And it reads, calculate the magnitude of the horizontal and vertical components of a tension of 8 Newtons in a string of 10 meters, which has one end fastened to the top of a flagpole of height 6 meters and the other end fixed on the ground. Now, it might not be easy for this to make sense to you if you don't have the right sketch. Now, we're being told it's fastened to the top of a flagpole, height 6 meters, right? But the string is of length what? The string is of length 10 meters, and it's fastened, right? So that means the string is taut. It's not just lying. It's not just hanging. The string is taut. And if it's of length 10 meters, then it has to be at some angle like this, because it can't be straight. Otherwise, the other 4 meters would just be lying around. So this is the string in question. It's fastened between those 2 points. And of course, the tension acts like this and like this. And we've been told the tension in the string is 8 newtons. So the question wants us to find the vertical and horizontal components of the tension. You can see that if we resolve for the tension could be resolved for like this, where we have the vertical force there and horizontal force there, or like this, where we have the horizontal force and vertical force. Realize that in this case, the angle of our concern would be this angle right there. In that case, to be that angle right there. I'm looking at the angle between the horizontal, the tension. We usually use the angle between the horizontal and the force, because then we know that the horizontal component will be that force times cos theta. And then the vertical component will be that force times sine theta. But if you consider the other angle, if you end up considering the angle between the vertical component and the force, then what was your F cos theta now becomes F sine theta, and what was your F sine theta now becomes F cos theta. So for consistency, we usually just go with angle between the horizontal and the force. So if I call that angle theta, then my work really is to find theta, but we don't really need to find theta if you can find cos theta and sine theta. Now realize that we have a right angled triangle, right? And we have the length of 2 sides. We have this as 6 meters and this as 10 meters. So we can easily find this side here. And by Pythagoras theorem, if you use Pythagoras theorem, you know that this would be the square root of 10 squared minus 6 squared, and that happens to be 8. And if this is our theta right here, I know that the cosine of theta is the adjacent out of the hypotenuse, which is 8 out of 10, which is 0.8. And the sine of theta, which is the opposite out of the hypotenuse, is going to be 6 out of 10, which is 0.6. And so the horizontal component of the tension is simply going to be 8 newtons times cos theta, which is 0.8. That gives us 6.4 newtons. And the vertical component of the tension is going to be 8 newtons times 0.6, 8 sine theta, which is 4.8 newtons. Because what we really have is, we have this as our force, right? And so this one resolve is going to be F cos theta. This is theta. And then this would be F sine theta. That's really what we have. Any questions here? I think once you get the sketch, the entire question falls into place. Okay, seems there are no questions. So I will hand over to the next presenter to take us through number 5. Thank you for staying this long. We should be wrapping up section A, and then the seminar will come to an end. Thank you for your patience. Please check out the channel. The recording will be uploaded there, but there's also some other content there. Join the group if you haven't. Thank you once again.
Brian, you're muted.
Oh, my apologies. Yeah, so maybe to rush through that, we're using trapezium rule with 6 ordinates to find the approximate value of that integral. So as I underlined those two phrases in our question, 6 ordinates and 3 significant figures, they are very key because they can determine whether or not you are to pass the question or to even get full marks. So we should note that you have been given ordinates and not intervals. And we should also note that our final answer must be to 3 significant figures. So we shall start by getting the height we are going to use, which is usually denoted by h. And you know that h is given by taking the upper limit, which was 1.5, minus the lower limit, which is 0.5, divided by the number of intervals, which in this case will be got by subtracting 1 from the number of ordinates. So we shall have everything out of 6 minus 1. That will give us 1 out of 5, which is 0.2. The h value. Then you are going to draw a table where we shall need to have x values, where we shall have x values and the corresponding y values. But we can start by letting y to be equal to 3 out of x plus x power 4, our integrand. Yeah, and we shall come up with a table of values. Yeah, let our y be equal to x subscript 3 out of x subscript n plus x subscript n power 4. Yeah. So this is our table. So our lower limit will be our first x value. So this is the column for x subscript n, and we are starting with 0.5. Then we shall have the corresponding y value. Then let us have a column. Okay, let us just have that. Yeah, first of all, let us be reminded that our formula for trapezium rule is a half times the height, then into brackets, the sum of y naught plus the last y value, then plus twice the sum of the values between the first y value and the last y value. So y1 plus all those values between plus the value before the last y value, y into n minus 1. Yeah, so let us actually create a column that will have the sum of the first, that will have the first y value and the last y value, which in this case will be y subscript 5. Then let us have a column that will have all the values between the first and the last y value. So from y1 up to y4, let us put them in a separate column. Okay, so our first x value is 0.5. So shall keep on adding the value of h until we reach the upper limit. So from 0.5, we shall go to 0.7, then 0.9, then 1.1, 1.3, and lastly 1.5. Okay. Our last column will be 4. Okay, our last row will have our sums. Yeah, so we shall get the corresponding y values for each x value. We shall start with when x is equal to, when the value of n is 0, or when x is equal to, xn is equal to 0.5. So we go back to our formula, which is y is equal to 3 out of x plus x power 4. We shall compute that formula in our calculator and populate our table with y values. Yeah, so that formula can be put in the calc and the values can be calculated at once. Yeah, I hope you've already been told that. So someone can put that value in their calc and help us with those values. Okay. Which values are you guys getting? So we have a 3.
Brian, there is for the first column, that's y naught 5 is 6.0625.
6.0625. 0625. So then a reminder, our answer has been told to, we must give our answer to 3 significant figures. So the values you're writing in our table should be, okay, in this case, you can use 4 decimal places. Yeah, but our final answer shall be to 3 significant figures. Let us use more figures than what our final answer should be to. Then what's the y5 value? Okay, y1.
Y1 is 4.5258.
5258. Then y2?
3.9894.
Y3.
4.1914.
1413.
1914.
14, okay. Then
5.1638.
and lastly Y5 is 7.06
0625.
Okay. So we are writing them separately because of the way our formula is. So just for convenience. So for this value here, we shall sum up Y0 plus Y5, and what shall we have? Shall have 13 point. Is it 125?
Yes.
Then the sum of Y1 to Y4.
17.8704.
17.8704. Okay, thank you. Yeah, then we shall go to our formula and get the integral of what they wanted us to find. 3 out of x plus x power 4 with respect to x will be approximately equal to a half times the height, which was 0.2, then into the sum of the first and last ordinate, which is 13.125, plus twice the sum of all the ordinates between the first and the last of the y values. Okay, so what do we get?
This one. This one. Yeah. 4.89 3SF.
4 point. Oh, you can first give the answer to 4 decimal places and then round off.
Okay, 4.8865.
65, yeah?
Yes.
But they wanted that answer correct to 3 significant figures. So we shall round off to 3 significant figures, which will give us 4.889 3SF, which is what they wanted. So we use approximate symbols because these are numerical methods. The answers we are getting are not exact. They're approximate values. Okay, then lastly, number 8, which is from mechanics. They tell us that a body of mass 500 kilograms accelerates uniformly from rest at 2 in I minus 3 in J meters per square second. And then let's find the power developed after 4 seconds. So we have been given the mass as 500 kilograms. We have been given the acceleration in vector form as 2 negative 3. And then they want us to get the power developed after 4 seconds. So power can be got using various methods, but for this particular case, we can get power. Okay, let me abbreviate it as P, from the dot product of the force, the vector force, and our velocity. So our task is to get that force and then the velocity after 4 seconds. Our force will be got by remember that formula. M dot, the acceleration. M is a constant and then the acceleration is variable. So our mass is 500 and our acceleration is 2 negative 3. So when we dot those two, shall get 1000 and then negative 1500 as our force. Then our velocity, you can still get since this is uniform acceleration, we can use our equations. For velocity, it can be got from v being equal to the initial velocity plus acceleration times time. So we are looking for the velocity that the body had after 4 seconds. In the question, they told us that it accelerated uniformly from rest, which means that our initial velocity was 0. So we have our initial velocity as 0, and then we have our acceleration as 2 negative 3. And us to get the velocity after 4 seconds. So our velocity will be 0 plus 8 negative 12. So that's our velocity. So we have our force and we have our velocity, which means that we can get the power using those two, since power is the dot product of the force and the velocity. Of course, the force is in newtons and the velocity is in meters per second. So our power will be equal to the dot product of the force, which is 1000, then negative 1500, dot the velocity, which is 8, negative 12. So when I dot that, I'll have 8000 plus, is it 18,000? It's 18,000. And we shall have our power as 26,000. We're working with our SI units, so yeah, those will be watts. So the power developed after by that body after 4 seconds is 26,000, which brings us to the end of question 8. Okay. All right. Yeah, thank you very much for joining us for this discussion. We are very happy to have you. We're very happy to have you. And the link to the YouTube channel has been shared in the chat. So the recording will be posted there after. So in case you missed out any questions, or if the discussant was very fast, you can go back and review on the YouTube channel. Math up. Yeah, the YouTube channel also has various topics that have been discussed. So in case you want to learn particular concepts better, you can go to the channel and look for those concepts. Yeah, let's close with an opening prayer from, I'll choose someone from Faustina. With a closing prayer from Faustina. Sorry. Okay, I'll pray save time. Heavenly Father, we thank you for this seminar we've had. We thank you for each and everything that has been taught. We thank you for the new concepts we have learned. We thank you that you've helped us to consolidate concepts that we already knew. We pray that may you guide us in our academic journeys, help us understand whatever we shall be learning, and help us understand each and everything we are revising. And once our final exams come, pray that may we pass with flying colors. In the mighty name of our Lord Jesus Christ, we prayed. Amen.